Good morning, everyone, or good afternoon, or good middle of the night, like I'm slowly approaching. I just wanted to say hi. I know we are entering an unknown period of time, and this is all new to me, just like it's new to you guys. So we'll get through it together. Just bear with me as I kind of start to get my balance here and figure out the best way to do this for you guys and being able to do it when my kids aren't running the show. So I hope everybody is staying healthy, and please make sure that whatever assignments I'm giving, that even if I'm giving all the work and all the answers, that you guys are trying them on your own first. And I also wanted to let you know that I graded the big quiz, the 7172 quiz, and I've been trying to scan them in so that I can send them to you guys. So I will do that over the course of like the next day or so. I have most of them scanned in. It's just going to take a while. So hang in there, and I can't wait to see you guys in person again. And I will let you know the best way to kind of reach out to get help. I'm going to set up a Google Meets eventually, so that with some certain times that I'll be available if you guys want to log in, or if you have questions, or you just want to say hey. So hang in there. Bye. Today's teaching assistant is
Alana!
I've been staring at the edge of the water long as I can remember, never really knowing why. I wish I could be the perfect daughter, but I come back to the water no matter how hard I try. Every turn I take, every trail I track, every path I make, every road leads back to the place I know where I cannot go, where I long to be. See the line where the sky meets the sea, it calls me, and no one knows how far it goes. In the wind, my sail, the sea stays behind me. One day I'll know. If I go, there's just no telling how far I'll go. I know everybody on this earth.
all right. So we are going to take a look at L'Hopital's rule again, and we are going to do some that are a little different than the ones that we did before. Some of them will be a little more challenging, and some will just be some things that you guys haven't seen in a long, long time. So we use L'Hopital's rule when we do direct substitution before doing anything else, and we end up with the indeterminate form. So remember, your indeterminate form is 0 over 0, infinity over infinity, negative infinity over negative infinity. So when we take a look at this one, you must first verify that it is the indeterminate form. So if we were going to go off and we have 2 times the sine of pi squared, well, our sine of pi, everyone think, 0. So 2 times 0, we're going to end up with 0. And then 1 plus the cosine of pi. Well, your cosine of pi is going to be negative 1. So this is, in fact, 0 over 0. So we can use L'Hopital's rule. Now, remember, L'Hopital's rule tells us that we can then do, so if I'm going to go ahead and I'm going to do L'Hopital's rule, because I know that that ended up equaling 0 over 0. Well, now I'm going to be looking for the limit as x is approaching pi of the derivative of my numerator and the derivative of my denominator. Well, the derivative of my numerator, it's been quite a while since you guys have gone through and done these. But just a reminder, when you go to look for the derivative of 2 sine squared of x, well, if I'm looking for the derivative of 2 times the sine of x squared, well, this ends up being a chain rule problem. So I know that I can bring my exponent to the front, so then I'm left with 2. Wait, no, I'm not. That's going to be a 4. Sine of x. But then I need to take the derivative of the inner function, which was sine of x, which is going to be cosine x. So, I am not, whoa, I ran out of room already. Okay, so when we go through here now, I'm going to have 4 sine x cos x all over, well, 1 plus the cosine of x. Well, the derivative of that would be negative sine x. So now, when I take a look at where we are right now, I'm not going to try to plug this in yet because I want to try to make it as simple as I possibly can. So I can see that those sine of x's are going to cancel. So I know now that I'm looking at the limit as x is approaching pi of negative 4 cosine of x. Well, let's see. Do I end up with that indeterminate form again, or can we actually evaluate? The cosine of pi. Well, our cosine of pi is going to be, everyone think, negative 1. So I don't end up with one of the indeterminate forms again. So now I can drop my limit notation and I can just do my direct substitution that I have negative 4 times negative 1, which is going to leave me with 4. So in this problem, we've ended up with 4. Now, I am going to do another example that's going to be slightly different than the ones that we saw before, and hopefully I can figure out how to keep it all on the screen. Now, ooh, I think I figured out a solution. I rotated my board. We'll see how this goes. All right, so in our next example, this one's going to be a little different because we haven't dealt with the ones that are the infinities yet. So if I'm looking at the limit as x approaches infinity of x to the third over e to the 2x. Well, let's think about what you guys know about the graphs. Well, if it's x cubed, you know as x's are going to infinity that this is going to be infinity, and that the graph of e to the 2x, hopefully you know that that's exponential growth, so you're also at infinity. So we have verified that this is going to be our indeterminate form. So I'm going to go ahead and I'm going to apply L'Hopital's rule. L'Hopital. All right, now that you're in your own homes, you can try your French accent even if spit's flying. So, if we have our limit as x is approaching infinity, well, now I want to try to find derivative of my numerator over the derivative of my denominator. Well, my denominator, it would be e to the 2x times the derivative of my inner function, and my inner function's 2x, so it would be 2e to the 2x. Well, okay, so if I plugged in x again, I'm still left with infinity over infinity. So I'm doing L'Hopital's rule again. Well, this time around, I have 6x over the derivative of the denominator, which ends up being 4e to the 2x. Well, you guessed it. I am looking at infinity over infinity again. So I'm going to do L'Hopital's again. So the limit, let's see if I'm still on the board, almost, as x is approaching infinity of 6 over 4e to the 2x. Well, now let's take a look at what's happening. Well, the limit as x is approaching infinity of 6. Well, that would be 6 over 4e to the 2x. Well, if this is going to end up being infinity, we're going to end up with 6 over really, really, really big numbers, which means then that my limit is going to be 0. Now, I'm going to end this video, but I will do one more little short one on another L'Hopital's problem for you guys. So sit tight. All right, so here's one last example for you guys. I might do one more after this, but it's quite a challenging problem. I think it's good for you guys to see it, but I also don't want to incite panic that I would give you something like that on an assessment right after we return to school. So when we take a look at this one, if I have the limit as x is approaching infinity of this expression here, well, if I was going to plug in infinity, or just what I know about my graphs, I can tell you that this would be going towards infinity and this would be going towards infinity. So this does in fact give us infinity over infinity, which is one of our indeterminate forms. I expect to be able to see this with you guys. Now, because it's infinity over infinity, that means then that we're going to end up going ahead and applying L'Hopital's rule. Now, the derivative of my numerator is 2, and the derivative of my denominator is 4. So the limit as x is approaching infinity of a constant should just end up equaling said constant. Now, if you recall from way back when we first started looking at limits, we said that if we were dealing with these polynomials, that we could look at the ratio of our leading terms, right? And so when we did that for that one, we still would have ended up with 1/2. Now, I'm going to give you guys quite the fun problem here that is going to have a lot of different things going on. Lots of chain rule, lots of trig derivatives. So this problem is the limit as x approaches 0 of x cubed over x minus the tangent of x. And I want you guys to give it a shot on your own. So, pause the video, or maybe I'll stop the video and give it a shot, and then I will post what the solution is.